All right, here we go. This is part 2 of your Chapter 5 Trigonometry final exam review. All right, we're going to start off on these problems just like we did on the last ones. They give us the sign of A, and they're telling us the sign of A is in quadrant 2. All right, the sign of A is the opposite over the hypotenuse, so it's going to be 12 over 37. So the Pythagorean theorem is going to give us that third side. So we have 37 squared. We're going to subtract the 12 because that 37 is the hypotenuse. Go ahead and square root that. The square root of 1,225 is, of course, 35. Now, one thing to keep in mind is this 35 is going in the negative direction on the x-axis. So I'm going to call that negative 35. All right, now it's going to be a good idea to write out all the other three ratios. So the sine of angle A here, again, angle A is right here. I'm not going to color code in this video. That just took way too long. So the sine of A, that one was given to us. All right, so that's 12 over 37. The cosine of angle A here is negative 35 over 37. And then your tangent. The last one is your tangent. The tangent of angle A is the opposite over the adjacent. So you got 12 over negative 35. All right. So now, this one is asking for the half angle identities. What are the half angle identities? That is going to be these three over here. So the sine of theta over 2, the cosine of theta over 2, and the tangent of theta over 2. The sine and cosine, very similar identities here. So let's see here. We have sine of theta over 2. Well, I think that's the first one. Let's see. Oops, wrong way. Cosine. The cosine of A over 2 in this case is going to be equal to plus or minus the square root of, I forgot, I think it's 1 plus, but I could be wrong. It is, it's 1 plus the cosine of angle A, and all over 2. All right, so looking at that. Now, the plus or minus thing on the inside, or no, I'm sorry, on the outside, we have to kind of figure out, okay, where is cosine of A over 2? Keep in mind, angle A is in quadrant 2. All right, if I take that angle and I cut it in half, it ends up in quadrant 1. All right, so it's going to end up somewhere in quadrant 1. I don't know where exactly, but I do know it is in quadrant 1. I know every single trig function is positive in Q1. So we know this is going to be the positive variation of this. All right, so with that in mind, I'm just going to keep simplifying here. We have square root of, we have 1 plus, let's see, cosine, that's going to be negative 35 over 37. And then that is all divided by 2. All right, now, from here, we could do this by hand. I made my class do this by hand a lot, and I think they still hate me for it. So why don't we just plug it into our calculator? So ignore the square root for now, okay? So we are going to make this fraction. You have the 1 on top, and then plus the negative 35 divided by 37. All right, that's all in the numerator. All right, then you have this 2 on bottom. It gives you a decimal, but we can take this decimal and turn it into a fraction. Now, if we had not, or if we had added the square root in there, it would not have turned into a fraction. So that's something that I would just really recommend you avoid in the beginning. So I think it was 1 over 37, right? When you go to type this into your calculator, only type the inside into the calculator, because then we can get a fraction out of that. All right, so you have 1 over 37. That's all inside the square root. So if you wanted to think about this, this is the square root of 1 over the square root of 37, and we need to rationalize this. Square root of 1 is 1. So I'm going to multiply both the top and the bottom by 37. So we get the square root of 37 all over normal 37. Right, and that is our final answer. Right. I'm going to skip the tangent for now. I'm going to go down to the sine because the sine is a very similar formula. All right, it's plus or minus the square root of, it's 1 minus cosine of a this time. So both the sine and the cosine half angle identities use that cosine in there. All right. And again, for the same reason as last time, we're going to take the positive one because the angle ends up in the first quadrant. All right, so this turns into 1 minus the cosine. Well, the cosine was negative 35 over 37. So negative 35 over 37. And that all gets divided by 2. Right? So again, let's plug that one into the calculator. Let's see what we got. I'm going to cheat. I'm going to go up here. I'm just going to copy and paste this down. And then I'm going to change that plus sign to a minus. Let's save me just a little bit of typing in. Again, we do get that decimal. Let's turn it into the fraction. And that gives us 36 over 37. So we have 36 over 37. All right, and keep in mind this is square rooted still. Right? So what this turns into, this is 6 over the square root of 37. Right? Now, rationalizing that one, we end up with 6 square root of 37 all over a normal 37. And if that is a fraction you can reduce, you should reduce, but 6/37 does not reduce. All right, so we're going to call it a day on that one. That is our final answer here. All right. Now, back up to the tangent. The tangent one I saved for last because the formula is different. All right, 1 minus the cosine of theta over the sine of theta. All right, so this one turns into, I'm just going to write that down, 1 minus the cosine of theta over the sine of theta. All right, let me double check that. Okay, and they shouldn't be thetas, they need to be a's. All right, this is angle A we have here. So we have an A here, an A here. All right. So plugging in, this is going to be 1 minus the cosine. That was negative 35 over 37. All over this sine. I don't remember what the sine was. That's why we wrote them all down in the beginning. 12 over 37. This one's actually a little bit easier because there is no square root involved on this one, so that's kind of nice. But we can type it in a calculator all the same. So make your fraction, alpha y equals, all that good stuff. 1 minus negative 35 divided by 37. All right, that's going to go on top. And then you have 12 divided by 37 goes on bottom. All right, hey, that's a 6. That's a nice clean number for us. So this equals 6. All right, and there we have it. That is your half angle identity. All right, the other one is the double angle identity. All right, so if I take this angle and I double it, what is that exact value going to be? All right, so we have the tangent now. Tangent is, it's in quadrant 3. All right, so tangent is the opposite over the adjacent. All right, so here is our theta right here. All right, this one is a Pythagorean triple that I remember. So that is a square, that is a 13 right there. That hypotenuse is 13. Pythagorean theorem to confirm it. And then one thing I did forget is this is going negative x direction, right? And it's also going negative in the y direction. So both of those are negative. So this is really, you could think of it as negative 12 over negative 5. But a negative divided by a negative is a positive. So that's why up top we don't write those in there. But that does affect the sine and the cosine. So that's just something that we have to be mindful of here. So the sine of theta is equal to negative 12 thirteenths, right? The cosine of theta here is equal to negative 5 thirteenths. And the last one, your tangent of theta is equal to, well, we already had that one given to us. It's 12 fifths. And they want us to find all the other ones. Now, these identities are a little bit more involved here, the double angle identities. And notice how there's 3 of them for cosine. All right, it really does not matter which one of these you pick. I think the third one are probably the easiest, but if you want to do the top one, by all means, go for it. But those are a little bit different. So let's see what our first one is, the cosine of 2 theta, right? So again, it does not matter which one you pick. I kind of like the middle one more, so that's what I'm going to use, right? So the cosine, this is 2 times the cosine squared of theta minus 1. Well, we know what the cosine is, so this is 2 times cosine is, I'm blocking it right here, -5/13. All right, we're going to square all of that, and that's -1. And again, if you want to do it by hand, by all means, I'm sure you're very capable of it. But if you don't, then, go to the calculators, throw it all in there. You got -5/13. If you do this, make sure you use parentheses because you are squaring a negative. Your calculator might spit out the wrong answer if you don't use those parentheses here. But this gives us -119 over -169. Right, so that's the cosine of 2 theta. We don't have to worry about the plus or minuses here because that's kind of taken care of in the formulas. Taken care of in the formulas, whatever. Tangent. Now the tangent of 2 theta is 2 tangent theta over 1 minus tangent squared. One minus tangent squared of theta. All right, so that's what we got. I'm going to plug everything in here. So we're going to have a fraction inside of a fraction on this one. That's not a big deal. The tangent we said was 12/5. So this is 2 times 12/5. That's on the top of your fraction, and then the bottom, it's 1 minus 12/5 squared. Let's throw all of that in. Let's see here. Alpha y equals a fraction. We have 2, then we have another fraction. That's going to be 12/5. And then 1 minus. We're going to have 12/5. Close that one up, square it, and then press enter, and that's going to give us -120 over 119. There's your tangent. And the very last one, and then we can, end unit 5 here. This is the sine of 2 theta. It's 2 sine theta cosine theta. So this one is 2 sine of theta as the cosine of theta. Right? So we're going to have 2 times, I don't remember what sine is, so let's go back up and look. -12/13. All right, the cosine is -5/13. All right, let's see. That should be a 13 right there. We're going to have 60, 120 on top, and then 169 on bottom. And there we have it. That is how we use the double angle identities. And again, it all boils down to, I would really, really recommend finding your ratios first, and then it's just a matter of plugging them into the formulas. But that's all there is to Unit 5. Sometimes we had some nice numbers, sometimes we had some ugly numbers, but all of those came out relatively clean, right? So then one last thing to recommend is when you are typing these into your calculator, do not put the square roots in there. Just kind of just tack it on at the end when you're writing your answers down, right? But there we have it. That's Unit 5, and we'll see you guys in the next one.